college algebra students. Today we're going to look at the first half of section P1, real numbers. The real numbers can be broken down according to the flowchart that you see on this slide. Real numbers are made up of both rational numbers and irrational numbers. Rational numbers can be written as a fraction or a ratio. Irrational numbers cannot be written as a fraction. They are numbers that do not end and they do not repeat. For example, pi is an irrational number, 3.14159265535 and so on. Integers are also rational numbers. They do not contain decimals or fractions. They are numbers such as -3, -2, -1, 0, 1, 2, and 3. The whole numbers start with the number 0 and then go on up 1, 2, and 3. One way to remember the whole numbers is that they start with a number that looks like a whole. The natural numbers are the numbers that you would naturally count. 1, 2, 3, 4, 5. Find the decimal form of the rational number. If it is a non-terminating decimal, write the repeating pattern. 1/3 as a decimal is going to be 0.3 repeating. So you're just going to write 0.3 with the repeat bar above it. Please do not round. If you're not sure what it is, you can use your calculator and just do 1 divided by 3. Press enter and it shows you the 0.3 repeating. 6/11, 6 divided by 11, same thing, is going to give you 0.54 repeating. So in this case you need the repeat bar above both the 5 and the 4. Okay, so we're going to approximate these numbers. The 0 is right here, which means this is going to be a -1, a -2, and a -3. So the first point is a -3. This one looks like it's right in the middle, so that's going to be -1/2. And then the inequality symbol that goes in the middle is a less than sign because -3 is less than -1/2. This time we're going to plot the numbers, so let's choose some place for 0 to be. So we'll put the 0 right there. And then -3.5, 1, 2, 3, there's your -3, and there's your -4. So -3.5 would be about right there. +1 would be right there. We have +1 here again, and then 16/3, 1, 2, 3, 4, 5 would be 5 1/3, so it's going to be a little bit bigger than the 5. So with regard to the appropriate inequality signs, -3.5 or 3 5/10 is less than 1. And then over here you would write 1 is greater than 16/3. Okay, bounded intervals. Bounded intervals on a number line are intervals that stop basically on both sides. So the notation for a bounded interval might look like this. You could have a square bracket and then A comma B, so two numbers there, and then another square bracket. That particular interval is closed, and the inequality would look like this. It would be A is less than or equal to B, sorry, not B, X, which is less than or equal to B. And then the graph is going to be a square bracket with an A under that, and another square bracket with a B, and everything in the middle. So while this notation sort of looks like an ordered pair, it's really describing an interval, all the numbers between A and B, including A and B because of the equal to sign. Now, if you use parentheses instead, then this is an open interval, and we use a less than sign. So the difference here would be that you would use parentheses when you graph this. And so it's all the numbers in between A and B, but it does not include A and B. Now, in the past, you may have used circles or dots instead. So another way to graph this, the closed one, would be with open circles, with closed circles. And another way to graph the open interval would be with open circles. Okay, now sometimes you can have mixed. So you might have a square bracket on the left and a parenthesis on the right. And we don't consider that open or closed. The inequality would be A is less than or equal to X is less than B. And the graph here is going to be a square bracket on the left and a parenthesis on the right. Or if you choose to do the circles, it would be a closed dot on the left and an open dot on the right. And then finally we can go the other direction and have a parenthesis on the left and a closed bracket, a square bracket on the right. And that would be A is less than X is less than or equal to B. Parenthesis on the right, square bracket on the left. So this is everything between A and B, not including A, but yes, including B. And then on this side, we're going to do an open circle for the A and a closed circle for the B. At any point, if you have questions, please make a note and you can ask me about those when you get to class tomorrow. And remember, you can stop the video and rewind and rewatch as many times as you need to. Unbounded intervals are intervals that go off to infinity in one direction or the other. So, for example, you might have a square bracket with an A, comma, B, not a B, an infinity. And this means that your interval is going to start at A and go off to positive infinity. So this one is, the inequality is X is greater than or equal to A, and the graph is going to be a square bracket going to positive infinity, and we label this with an A underneath right there. We could also do a parenthesis A to infinity, and this one is open because both sides have the parentheses. And here we do X is greater than A, no equal to sign because we're not including the A. And then we have a parenthesis going to positive infinity. Okay, we could do a parenthesis and then negative infinity to B with a square bracket, and that will be X is less than or equal to B, and this time your graph is going to go off to the left towards negative infinity. And if you have a parenthesis on the right side, then again you have an open interval, and this time we have X is less than B, and so it's a parenthesis going to negative infinity. And again, just like before, all of these could be done with closed and open circles instead of the brackets. And it doesn't matter to me if you use brackets or parentheses or open circles and closed circles. And Johnson County doesn't care either way either. So it's totally up to you if you prefer the circles or the parentheses and brackets. We do have one more that I'm going to add here, and that would be negative infinity to positive infinity. This is actually the entire real number line. And you can write that as an inequality by saying negative infinity is less than x is less than positive infinity, and it's just the entire number line, just like that when you graph it. For each inequality, describe the subset of real numbers. So x is greater than or equal to negative 2. You're just really going to write that in words. This is all numbers greater than or equal to negative 2. For number 8, this one is all real numbers greater than or equal to 0 and less than 5. Part B, sketch the graph. You're going to draw a number line. The point that we're given here is negative 2, so I'm just going to put a negative 2 right there. It's greater than or equal to, so you need a closed circle or a square bracket, either way. And since x is bigger, it needs to go off to the right. And I'd like you to either use a different color or make your line really dark so that it's clear which direction your line is going. Over here, I'm going to draw the number line, and we're going to put 0 and 5 on the number line. And the bracket on the 0 should be closed or square, and on the 5 it should be open or a parenthesis. So there's your graph for that one. And then for part C, state whether the interval is bounded or unbounded. This one is unbounded because it goes off to infinity. This one, number 8, is bounded because it stops on both sides. In order to order the numbers from smallest to largest, we're going to change all of these to decimals and line up the decimal points. So 26/15 when you divide is 1.73, and the 3 repeats. Radical 3 is 1.73205. The next number is given to us as a decimal already. 381/220 is 1.7318, and then radical 10 minus radical 2 is 1.748. So the smallest number is 381/220. The next smallest number is 1.7320. And then radical 3, then 25/15, and the largest number is radical 10 minus radical 2. And again, we get that just by comparing the decimal places and seeing which one is smallest.